In this video, we'll review 5 different methods for counting the number of possible outcomes in a variety of situations. Multiplication counting rule, factorial rule, permutations with different items, permutations with some items that are identical to others, and combinations rule. This section requires much greater use of formulas as before, so I will show you how to perform calculations using StatCrunch and TI graphing calculators. Not all counting problems can be solved with these 5 methods, but they do provide a strong foundation for the most common real applications. Multiplication counting rule is used to find the total number of possibilities from some sequence of events. For a sequence of events in which the first event can occur n sub 1 ways, the second event can occur n sub 2 ways, the third event can occur n sub 3 ways, and so on, the total number of outcomes is n sub 1 times n sub 2 times n sub 3, and so on. Let's calculate what is the probability of a hacker guessing a passcode. When making random guesses for an unknown 5-digit passcode, each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. What is the total number of different possible passcodes? 5-digit passcode consists of 5 possible places. There are 10 different possibilities for each digit. There are a total of 10 digits. So the total number of different possible passcodes is n sub 1 the first way times n sub 2 the second way times n sub 3 times n sub 4 and times n sub 5. 5 different ways. 10 possibilities in the first place, 10 digits, times 10 digits in the second place, times 10 digits in the third place, times 10 digits in the fourth place, and 10 digits in the fifth place will give us 10 to the fifth power, or 100,000 possible passcodes. Given that all the guesses have the same chances of being correct, what is the probability of guessing the correct passcode in the first attempt? Because all of the passcodes are equally likely, the probability of getting the correct passcode on the first attempt is 1 out of 100,000, or 0.00001. Factorial rule is used to find the total number of ways that n different items can be rearranged in different ways. Order of items matter. The factorial symbol, exclamation point, denotes the product of decreasing positive whole numbers. For example, 4 factorial is equal 4 times 3 times 2 times 1 equal 24. By special definition, 0 factorial is equal 1. The factorial is based on the principle that the first item may be selected n ways, the second item may be selected n minus 1 ways, and so on. The rule is really the multiplication counting rule modified for the elimination of one item on each selection. Before we proceed with the example on using factorial rule, let me show you how to use StatCrunch to find a factorial of a number. Open your StatCrunch, and we want to find a factorial of 4. Click Data, Compute, Expression. Build the expression. In the Functions menu, find Factorial, click Add Function. In the top box, you will see Factorial. Type the number you want to find the factorial for. I'm going to type number 4. Click OK and compute. The answer will appear in the first row, and it says factorial 4. To calculate the factorial on graphing calculator, first type the number that you want to find the factorial for example 5, then select Math and go 3 steps to the right to Probability, PROB. Then go 4 steps down or click 4. 5 factorial, enter 120. Now let's look at the following example. A statistics researcher must personally visit the presidents of the Gallup, Nelson, Harris, Pew, and Zogby polling companies. Part A. How many different travel itineraries are possible? For those 5 different presidents, the number of different travel itineraries is 5 factorial. On the first trip, a researcher has 5 options to choose from. On the second trip, he has 4 options to choose from. On the third trip, he has 3 options to choose from, then 2 options, then 1 company is left. Note that this solution could have been done by applying multiplication counting rule. The first person can be any of the 5 presidents, the second person can be any of the 4 remaining presidents, and so on. The result is, use the StatCrunch or TI graphing calculator. You know how to do that now? 5 factorial is equal 120. The second part of the question. If the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? There is only one itinerary with the presidents visited in order of age, so the probability is 1 out of 120. Permutations and combinations. How they're different. Permutations of items are arrangements in which different sequences of the same items are counted separately. The later arrangements of A, B, and C are all counted separately as 6 different permutations. We can put A first and then BC or CB. We can put letter B first and then AC or CA. Or we can put C first and then AB or BA. Combinations of items are arrangements in which different sequences of the same items are counted as being the same. The later arrangements of A, B, C are all considered to be the same combination. To remember when to use permutations and when to use combinations, remember the mnemonics, permutations, positions, where the alteration reminds us that with permutations the positions of items make a difference. Combinations, committee, which reminds us with members of a committee, rearrangements of the same members result in the same committee, so order does not count. For example, if you have 10 people to choose from, and you need to choose 3 positions, president, vice president, and administrative assistant. That will be permutations because the positions do matter. But if you have 10 people and you need to choose 3 for the committee, then each committee member can do the job of the other committee member. So remember, permutations, positions, combinations, committee. Permutations, order does matter. Combinations, order does not matter. When n different items are available and r of them are selected without replacement, the number of different permutations, remember, order counts, is given by the formula NPR is equal n factorial divided by n minus r factorial. Let's look at the following example. In the horse race, a trifecta bet is won by correctly selecting the horses that finish first and second and third. You must select them in correct order. The 140th running of the Kentucky Derby had a field of 19 horses. Part A. How many different trifecta bets are possible? There are 19 horses available, so n equals 19, and we must select 3 horses, so r equals 3. The number of different sequences of arrangements is found by the formula. NPR is equal n factorial divided by n minus r factorial equals 19 factorial divided by 19 minus 3 factorial is equal to, let's do it by hand first and then I'll show you how to do it on StatCrunch. It's really not that bad to do it by hand. 19 factorial is 19 times 18 times 17 times 16. Don't worry, we're not going to go further because 19 minus 3 is equal 16 factorial. So we're not going to multiply by 15, 14, 13, 12, and so on. We're going to leave it as 16 factorial. 16 factorial and 16 factorial is reduced, and all we need to multiply is 19 times 18 times 17 is equal to 5,814 different possible arrangements. If a bettor randomly selects 3 of those horses for trifesta bet, what is the probability of winning by selecting California Chrome to win first, Commanding Curve to win second, and Danza to win third, as they did? Well, because the order matter, there is only one of those arrangements. So the probability that if one of those arrangements is randomly selected is 1 out of 5,814. Let's now look at how to use StatCrunch to calculate permutations. The total number of horses, N, was equal 19, and we must select 3 of them without replacement. So R equals 3. Now go to Data, Compute, Expression, Build Expression. In the Functions menu, go to Permutations, select Permutation, select Add Function, and you have 2 spaces separated by comma. The first space is for N. N is equal 19, R is equal 3, then click OK and compute. The answer will be given in one of the available rows, 5,814, the same answer that we got from manual calculations. Now let's do the same problem on TI Graphing Calculator. First, type the total number N, in this case 19, then click Math and go to the right to Probability, then down to NPR, or you can click 2, Permutations, enter, then enter the number R, in our case 3, click enter again. The answer is 5,814, the same answer that we got by manual calculations and on StatCrunch. The number of different permutations when N items are available and all of the items selected without replacement, but some of the items are identical to others, is found by the formula. N factorial divided by the first identical subject factorial times the second subject that's repeating or duplicate times however subjects are duplicating, where N1, N2, and so on, their items, they're identical to each other. For example, when designing surveys, pollsters sometimes repeat a question to see if a subject is thoughtlessly providing answers just to finish quickly. For one particular survey with 10 questions, 2 of the questions are identical to each other, and 3 other questions are also identical to each other. For this survey, how many different arrangements are possible? We have 10 questions, so the total number of items is 10, with 2 that are identical to each other, and 3 others that are also identical to each other. And we want the number of permutations. Using the rule for permutations, with some items identical to each other, n factorial divided by n1 factorial times n2 factorial times and so on, n kth factorial equal to 10 factorial divided by 2 factorial times 3 factorial. Notice that 2 factorial times 3 factorial is not equal 6 factorial. We must break the numbers down. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1. We can reduce some items in the numerator and denominator and simplify the leftover items. 10 times 9 times 8 times 7 times 6 times 5 times 2. Let's use the calculator for this. The answer is 302,400. It means there is 302,400 different possible arrangements of the 10 questions when the 2 items are identical and 3 other questions are also identical. And lastly, combinations rule. Remember, combinations is when order does not matter. When n different items are available, but only r of them are selected without replacement, the number of different combinations, order does not matter, is found by the formula NCR equal n factorial divided by n minus r factorial times r factorial. Let's look at the example with the lottery. In California's Fantasy 5 lottery game, winning the jackpot requires that you select 5 different numbers from 1 to 39, and the same 5 numbers must be drawn in the lottery. The winning numbers can be drawn in any order, so order does not make difference. Part A. How many different lottery tickets are possible? There are 39 different numbers available, so n is equal 39, and we must select 5 of them without replacement, so r equal 5. Because order does not count, we need to find the number of different possible combinations. NCR is equal n factorial divided by n minus r factorial times r factorial equal 39 factorial divided by 39 minus 5 factorial times 5 factorial equal, don't worry, we are not going to multiply 39 times 38 times 37 and so on. We just need to simplify the denominator part first. 39 minus 5 is 34 factorial times 5 factorial. Now let's break down 39 factorial. 39 times 38 times 37 times 36 times 35 times 34, and I'm going to stop right here because then we'll multiply by 33, 32, and so on, which is 34 factorial, which we have in the denominator as well. We just simplify 34 factorial and 34 factorial and break down factorial of 5. 5 factorial is equal 5 times 4 times 3 times 2 times 1. Now let's simplify. 5 and 35, 7. 4 and 36, 9. Then we simplify 3 and 9, 3. 2 and 38, 19. And now we just multiply 39 times 19 times 37 times 3 times 7. The answer is 575,757. Of course, there is an easier way to find the combination of items by using StatCrunch. Go to Data, Compute, Expression, Build Expression, go down to Combinations, Add Function. You'll see 2 spaces to enter the total number, 39, and the winning numbers, 5. Click OK. Compute. The answer is 575,757, the same that we got by manual calculations. Combinations are located in the same place on TI graphing calculator as factorial and permutations. First type the total number n, in our case 39. Then go to Math, go to the right to Probability, down to Combinations, NCR, or you can click 3, click Enter, enter the number R, in our case 5, winning tickets, click Enter again, 575,757. Now, let's find the probability of winning the jackpot when 1 ticket is purchased. Remember in class, I asked you, what is the probability of winning a lottery? Now you can tell exactly what is the probability of winning a lottery that has 39 numbers and 5 of the numbers are the winning numbers. It's equal 1 over 575 1,757. Let's write it in decimal and percent. Remember, we can express probability as fraction, decimal, and percent. As a decimal, it's 0.000060174 rounded to 3 significant digits. In percentage, it will be multiplied by 100 and add the percent sign, 0.30174%. As you can see, probability of winning lottery is really low. Typical lotteries rely on the fact that people rarely know the value of this probability and have no realistic sense of how small the probability is. Coming up next, Chapter 5, Discrete Probability Distribution. We will learn about random variable and a binomial probability distribution. Stay tuned. Subscribe for the updates.